Okay, this guys is January 2022, paper 1H, so we have question 1, n is an integer, write down all the values of n such that n is this inequality. So n is bigger or equal to -2, so it can be equal to -2, it's an integer, so it has to be a whole number, so it can be -1, it can be 0 is an integer, it can be 1, and it can be 2, and because this is less than without the equal sign, it cannot be 3, so we stop there. And then it says represent, on the number line, represent the inequality y is less than or equal to 1. So we go to 1, we draw a circle, and because it's less than or equal, we color in the circle, that's important, and then we just draw a straight line to the left of the circle because it's less than, and it doesn't really matter how far you go, but you have to have an arrow on it. Okay, that's question 1. Question 2. Each time John plays a game, the probability he wins is 0.65. He's going to play 300 times. Work out an estimate for the number of times he wins, right? So it's just basically he's going to win he's going to win 65% of the time, and he's playing 300 times. So we just want to get 65% of 300, which is just this times 0.65. That's it. So it's 300 times 0.65, 195. So this is 195. Okay, question 3. The shaded shape is made up of 3 identical right angle triangles and a square. Work out the perimeter of the shaded shape. Okay, so the perimeter is obviously the length of the outsides. We have some of them. What we don't have is this, the length of the square, but we can find it. And I'm going to use this, they've given us 12.8 here, so I'm going to actually use that here. This pink line is 12.8. because obviously that's the same as this. Okay, and now using that, I can find this line here. Let's call it x. I can find it because it's right angles, guys. I can use Pythagoras. So I can say x squared plus 12.8 squared equals 16 squared. X squared equals 16 squared minus 12.8 squared. You could calculate those first, or you could go straight to the square root of this minus this. You have a calculator, so no. Why not? The square root of 16 squared minus 12.8 squared. Is 48 over 5, or 9.6. Okay, so this is 9.6. Okay, so we have x. So this is 9.6 because it's the square, and this is 9.6. The last length that we don't have is this one here, but we know this is 12.8. Well, actually, guys, that's slightly confusing. We know the full thing is 12.8. We know this length here is 9.6. So if I do 12.8 minus 9.6, which is 3.2, I'm sorry, that's not right. It's 2.8. No, it is 3.2, sorry. 3.2. Then I can just put 3.2 here. So the perimeter, let's call it P, is equal to, let's start with the 3.2. So it's 3.2 plus 16 plus 16 plus 9.6 plus 9.6 plus 16. So I'm just going that way. And this gives us, calculator please, 3.2 plus 16 plus 16 plus 9.6 plus 9.6 plus 16, which is 70.4. 70.4, and that's correct, guys. That is the answer. 4 marks. Okay. Question 4. Complete the table of values. Right, guys, this, I argue, is a very easy question because you have a calculator and you can put in the table here, you can write x squared minus 4x plus 3. Skip g of x. Start is -2. End is 4 because it goes -2 to 4. Sorry, -2 to 4. Step is 1 because it's just going up in ones, and it gives us this. So we've -2 is 15. The -1 is given and the 0 is given. It's then 1, 0, 2 minus 1, 1, 0, 2 minus 1, and finally 3 is given and it's 4, 3. Okay, he then says on the grid, draw the graph of this. So all I have to do, guys, is plot in these points. So I have -2, 15. -2 is here, 15 is here. -1, 8, -1, 8. 0, 3, 0, 3. 1, 0, 1, 0. 2 minus 1, 2 minus 1. 3, 0, and 4, 3. 3, 0, and 4, 3. Now, guys, he says draw the graph from -2 to 4, so you don't go any further than this. Now we're going to go down. Now, guys, draw it better than me. I'm just going to, my computer can do something very useful, which is this. So this is very good. Probably won't be able to draw it as well as me, but try to go through all the points. Well, make sure you go through all the points, and it should look like that. It's like a parabola, but you have to stop at -2 and 4. Okay, question 5. Use of SAT 8 exams. Here are his marks for the exams. For his results in all 8 examinations, the mode, sorry, for his results in all 8, the mode is 80, the median is 74, the range is 16. Find Yusuf's marks for the other 3 examinations. Okay, right. So, guys, we have, I like these questions. They're fun, but they're not easy. So I have 68, 72. I'm just going to spread them out a bit because I might need to put numbers in between them. 72, 75, 77, and 80. Now he says the mode is 80, so I have to put another 80 here. There has to be another 80. Now, because the median is 74, which means it's here somewhere, I can't put another 80. So that just means there's 2 80s and that's it. Okay, the median is here somewhere. The range is 16, right? So that means the biggest minus the smallest is 16. The biggest we know is 80 because, as I said, I can't put another one over here because the median is there. So I actually need the 2 of them have to be over this way. Because he says the range is 16, the biggest is 80, which means the smallest is 64. Now, how did I know that? Well, because now biggest minus smallest gives me 16. And then I just need to find if the median is 74. So as I said here, the median is 74. Let me draw a line here. This is the median, 74. So I need another one here because this is the middle, and it has to be 73. How do I know it's 73? Well, because if the median is bang in the middle, it has to be bang in the middle of 73 and 75. So I needed to add in that 73. Okay, so the only possible marks that he could have got are the 64, 73, and 80. Those are his other 3 exams. 64, 73, and 80. 64, 73, and 80. Okay, question 6. Work out the lowest common multiple of 36 and 120. So you could, guys, just kind of figure it out. But the more technical way is to say, okay, 36 is equal to, and we can write it like this, guys. 36 equals 2 squared times 3 squared, or 2 times 2 times 3 times 3. I'll show you why I write it out fully in a second. 120, same thing. I'm going to do 120 equals shift fact. It gives me the prime factors. So it's 2 cubed times 3 times 5. 2 times 2 times 2 times 3 times 5. Then I draw my Venn diagram. 1, 2. This is 36 and this is 120. And I go, right, what's common? Well, there's a 2, there's another 2, and there's a 3. So I have a 2, I have a 2, a 2, and a 3. And then what's left over is there's a 3 in the 36 and a 2 and a 5 in the 120. So the LCM is just all of these multiplied together. It's 3 times 2 times 2 times 3 times 2 times 5. And that is 6, 12, 36 times 10, 360. Obviously, guys, use your calculator. Okay, part B. A is this, B is this. Right, this looks hard, guys, but well, I'll show you that it actually isn't that bad if you know what you're doing. So the same thing, guys, with to get our lowest common multiple or highest common factor, the best thing to do is to draw your Venn diagram. Okay. Now, this is A and this is B. Okay, now the highest common factor is what's going to go in here in the middle. Now, let's look at the 5s. So A has got a 5 and a 5, and B has more than that because M is bigger than 2. So this is like 5 times 5 times 5 times some amount of 5s, but it definitely has 2 5s. So I'm going to put in a 5 and a 5 in here. 2 5s, 2 from there and 2 from there. I can't put any more because there's only 2 in A. Similarly, N is greater than 10. So N minus 5, 10 minus 5, that's 7 to the power 5. So there's 4 7s here, and there is more than 4 7s here. So I'm going to put 4 7s, or now, guys, I'll just write 7 to the power of 4 just because I'm running out of space. So I could write this is 5 squared as well. Let's just keep our consistency. So this is 5 squared, and this is 7 to the power 4. And then finally, same kind of thing. Here I have 111, and here I've got P11s, where P is bigger than 1. So same thing, I have 111 that's common. So the HCF, or the highest common factor, is just 5 squared. Well, it wants it in prime powers of its prime factors. So it's 5 squared times 7 to the 4 times 11. And that's it. Okay, question 7. Millie went on a car journey. She traveled from there to there to there to there, A to B to C to D. For A to B, she drove this many kilometers in 2.5 hours. For A to here, she drove this many kilometers at average speed of this. Okay, work out Millie's average speed in kilometers per hour for the journey from A to D. Give your answer to one decimal place. Okay, so to get average speed, we need the distance over the time. Easy, right? So let's just break it down. A to B. So A to B. She drove 245 kilometers in 2.5 hours. 2.5 hours. Okay, easy. We've got the distance and the time. Second one, from B to C, we have the distance, 2 20, but we don't have the time. Now, to get the time for this one, I need to do time is distance over speed. So the time from B to C is going to be distance over speed, and the speed was 80. So 220 over 80, what's 220 over 80? 2.75. So this is 2.75 hours. So that's distance and time. And finally, from C to D, her speed was this and her time was this, right? So now we have the time is 50 minutes, right? Be careful, guys. 50 minutes is 5 over 6 hours. Let's just write it as that, 5 over 6 hours. And this time it gives us the speed, so I need to get the distance. To get the distance, guys, I do speed times time. Speed times time. So this is speed is 72, and the time is 5/6. It's a fraction. It's not a full hour. It's less than an hour. So I'll leave it as a fraction. And 72 times 5/6 is, well, it's actually 60, guys, because that goes in 12. 12 times 5 is 60. So this is 60 kilometers. Okay, so total distance is equal to this plus this plus this, which is 245, 465, 525. So the total distance is 525. I think that's right. 280. Yep. And the total time is 2.5 plus 2.75. That's 5.25 plus 5/6. Right. Let's just do this here, guys. 2.5 plus 2.75 plus 5/6. So I'll just write it like this, 5 over 6. That gives me this, which is 6.0833. 6.0833. Then the average speed is equal to the total distance over the total time, which is 525 over 6.0833, and this is 525 over 6.0833 is 86.301. 86.301 to one decimal place, 86.3, and it's kilometers per hour, which is given there. Okay, question 8. Write this as an ordinary number, right? This is 5 with 4 zeros. 1, 2, 3, 4. Write this in standard form, right? Standard form, guys, has to be 6 times a number between 1 and 10 times 10 to the power of something. Now, because it's small, I'm going to be going backwards. 1, 2, 3, 4, 5. So it's actually 10 to the power of -5. Okay, next one. Work out this divided by this, right? Guys, you may have seen my previous videos where I talk about how they choose these massive numbers so your calculator cannot cope with it, right? So it's 4 times 10 to the 512 over 1.6 times 10 to the power of 700. Okay, so the first thing I'm going to do is 4 divided by 1.6. 4 divided by 1.6 is 5 over 2, which is 2.5. So that's nice, at least that's a nice number, 2.5. And then it's times 10 to the power of, so when I divide numbers with the same base, I can just subtract the powers. So 512 minus 700. 512 minus 700. This is like the second rule of indices. I'm sorry, I did divide it. Mistake. So sorry, it's 5112 minus 700. We subtract the powers, and it's minus 188, and the answer is minus 188. In fact, that is the answer. 2.5 times 10 to the minus 188. Question 9. Okay, nice. This is an easy question, guys. We just add the powers. This is x to the power of 9. Part B, I have to do 4 cubed separately. 4 cubed is 4 times 4 times 4, which is 64. Use your calculator. And y squared cubed in a bracket, we multiply the powers. That's y to the 6. So I'm left with 64 y to the power of 6. Next one, factorize this. Okay, this is one of the easier ones, guys. It's n. So to factorize it, we need brackets. I say it's easy because it's just like 1n squared. So this has to be n and n. And then I just need two numbers that multiply to give me 12 and add to give me minus 7. And the answer is minus 4 and minus 3. I know they're both going to be the same because that's positive, and I know they're both going to be minus because that's minus. If this was minus, they'd be different. So that's the answer. N minus 4 times n minus 3. Okay, question 10. John T has a storage container in the shape of a cuboid. Fine. He's going to paint the outside of his storage container apart from the base, which is shown in the diagram. He needs enough paint to cover the 4 sides and the top. Okay, each tin of paint covers that much. The cost of each tin of paint recently increased by 10%. After the increase, the cost is this. John T says, before the increase, I could have bought enough paint for less than £200. Show that he is correct. Okay, obviously, guys, this is a very annoying question from some examiner, but because there's percentages, there's area, there's money, there's a cuboid. It's annoying, but we are going to get a few things. We're going to get the area first, the area of this shape. Now we need, he's not painting the base, so I just need these 1, 2, 3, 4, 5 sides. So let's do this one first. 3, this one here, this side. This is 3 times 2.5. I'm gonna write up here, guys, area, let's call it area 1. 3 times 2.5, which is 7.5. Use your calculator. That's the same as this one, FYI. Okay, the one at the side here would be 3 times 12. Let's call this area 2. 3 times 12, which is 36. That is this back one here. And it's also the same as the front one. And then the top, let's call it area 3, is equal to 2.5 times 12. 2.5 times 12, which is 24, 30. Again, use your calculator. So I have 3 areas, but the total is equal to 2 of these, 2 area 1s, plus 2 area 2s, plus area 3, which is, that's a bit squashed, guys, which is, okay, I'll just write there. Obviously, guys, you're writing down here. So it is 15 plus 72 plus 30. Let's get out our calculator. It's 2 times 7.5, which is 15. 2 times 36 is 72, plus 72, plus area 3, which is 30, and this gives me 117. So my total area that I need to cover is 117. Okay, but we are going to, it's 117 meters squared. We're going to work out how many tins of paint I need. John T needs 117 divided by 15 is equal to, divided by 15 is equal to 7.8. Now remember guys, you can't buy 0.8 tins of paint, so 8 tins. He has to buy 8 tins to paint it all. Okay. After the increase, the cost of each tin of paint is this. Okay. He says before the increase. So let's say the tins of paint cost X. So before they cost X pounds. Okay, so I can say X times 1.1. Why times 1.1? Because we're going to increase it by 10%. So X times 1.1, when we increase what it was, we get 26.95, which means if I just want to get X on its own, I divide by 1.1. 26.95 divided by 1.1, and that is 26.95 divided by 1.1, 49 over 2, or 24.5. 24.5. Okay, so that's how much they cost before the increase. 8 times 24.5 is equal to, because we're getting 8 tins of paint, so this times 8 is 196 pounds. So he's correct. So John T is correct, because it would have cost him 196 pounds, which is obviously less than 200 pounds. Okay, don't like those questions, guys, but hey ho, they appear. Okay, it was 6 marks actually, guys, which is somewhat generous, right? Question 11. We have a sector of a circle. Fine. Gives us this. Calculate the area of the sector. Okay, that's not bad, guys. Area, there's a formula that's not in the formula booklet. It's pi r squared, area of the circle, times the angle over 360, because it's that fraction of the full circle. Pi times r, which is 7.1, squared, pi r squared, times angle 110 over 360, and that is equal to, let's do this, pi times 7.1 squared times 110 over 360, which is 48.39. 48.39. He wants it to 1 decimal place, so it's 48.4. Okay, question 12. Expand and simplify, right? I like to, guys, first do this. First do my n minus 4 times 3n plus 5. Okay, now you have to do first times the first, first times the second, second times the first, second times the second, minus 20. And this is simplified 3n squared minus 7n minus 20. And then we multiply by n. So n times 3n squared minus 7n minus 20 is 3n cubed, because we're multiplying n squared by n, 3n cubed minus 7n squared minus 20n. Okay, that's part A. Part B. Express as a single fraction in its simplest form. Okay, we need, guys, a common denominator, something that x goes into, 2x goes into, and 4x goes into. I am going to choose 4x because x goes into 4x, 2x goes into 4x, and 4 goes into 4x. Okay, plus something over 4x, plus something over 4x. Okay, so we'll do them all separately and then we'll just join them together. So x times what gives me 4x? Well, x times 4. So 3 times 4 gives me 12. 2x times 2 gives me 4x. So x plus 2 times 2. I multiply the top by the same thing that I multiply the bottom. This times 4, this times 2, and this times x, because I've multiplied the bottom by x, so I need to multiply the top by x. Okay, and this then equals all over 4x, 12, plus, I'm going to multiply this out, guys, 2x plus 4 and plus x, and then we're going to simplify this. I'm going to get 16, 12 plus 4 is 16, plus 2x plus x is 3x, all over 4x. There we go, that's part B. Question 13. Hector has a bag that contains 12 counters, 7 green, 5 red. He takes at random a counter from the bag, he looks at the counter and puts it back. He then takes at random a second counter from the bag, he looks at the counter and puts the counter back in the bag, right? Okay, because he's putting it back, guys, the probability stays the same. So if that's 7 over 12, this is 7 over 12. And this is 5 over 12. And this is 5 over 12. Like that. Okay. Then he says, work out the probability that both counters are red. Okay, so this is easy because I have my tree. It's just red and red. So this times this. So I do 5 twelfths times 5 twelfths, which is 25 over 144. Okay, well, that's part B. Okay, this is the next part. Megan has a jar containing 15 counters. There are only blue, green, and red counters. Hector is going to take at random one of the counters from his bag of 12. He will look at the counter and put the counter back into the bag. He is then going to take at random a second counter from his bag. He will look at the counter and put the counter back into the bag. Megan is then going to take at random one of the counters from her jar of counters. She will look at the counter and put the counter back into the jar. The probability that the 3 counters have different colors is 7 over 24. How many blue counters are in the jar? Okay, I was thinking, guys, that this was quite an easy question, and then I realized there was a part C, and this is obviously not easy at all. Okay, so in order for them to all be different, okay, for them to be different, we need a green and a red. Hector needs a green and a red, and then she needs to take a blue, because there are no blue. Hector has no blues. So we need the probability that Hector has 2 different colors. 2 different colors equals. So that is red, green and red, or red and green. So it's 7 over 12 times 5 over 12 plus 5 over 12 times 7 over 12. It's this times this, green and red, or red and green. So they're actually this, because he's putting them back, they're the same thing, but it's 7 over 12 times 5 over 12. 7 over 12 times 5 over 12 plus 5 over 12 times 7 over 12. Okay, and that is 35 over 144 plus 35 over 144, which is 70 over 144. That you can use your calculator. Okay, so now he has 2 different colors. We just need, she's going to take one of her counters she's going to take one of the counters from her jar. She will look at the counter and put it back. The probability that the 3 counters are different. How many blue counters are in the jar? Okay, so then we need, Megan has to get a blue counter. So the probability that Megan gets blue probability she gets blue, is however many blue there are in the jar, let's call that X. So it's X, that's what we're going to be trying to find, out of, there are 15 counters in her jar, so it's X out of 15. So now we can say that this happening, this 70 over 144, because he has to get two different colors, and which means I'm going to multiply this, so this happening and this happening, that's the only way they're going to get three different colors, is 7 over 24, because he tells us that's the probability. And then essentially find X. And then, so this is the hard bit done. Once you have this, guys, it's not easy, but we can solve this however you want. You could simplify it first. 70 over 144, for example, is 70 over 1444 is 35 over 72. So this is 35 over 72 times X over 15 equals 7 over 24. Now essentially what you're going to do, guys, is you're going to multiply. So to get X on its own, this is like, I'm going to do this in one kind of quick go, but hopefully it makes sense. So I'm going to multiply by the denominator, which is actually 72 times 15. I'm going to multiply the 7, multiply across by both of these. So it's 7 times 72 times 15. This times this and this. And then I'm going to divide by the 24 that's already there, and I'm going to divide by this 35. I'm going to do all that in one go, and this will tell me how many blue counters are in the bag, so are in the jar. It is 7 times 72 times 15 over 24 times 35, 9. And you know you're right when you get an answer like that. Obviously it has to be less than 15, it has to be a whole number, so that's definitely right. And guys, you could have even not bothered simplifying here. You could have just multiplied by this times this and divided by 70, and you'd have got the same answer. Okay, that's question 13. Question 14. A, B, C, and D are points on a circle. Center O, okay, we have, this is 55 degrees. This is the diameter, guys, which is important. And this is work out the size of angle ADB. So we're trying to find this angle here. Let's call it X. That's what we're trying to find. This is 55. So guys, definitely the thing to note is, because this is a diameter, this is 90 degrees. Because this is a semicircle. Now guys, it says give a reason for each stage of your working. You have to say angle ABC equals 90 degrees because, and then you have to write, again guys, I'm not going to write it, but you have to write it because angle in a semicircle is 90 degrees. Then we're going to say 55 plus 90 plus this, let's call it y, plus y equals 180. And again, he says give a reason, so put a reason for this. It's because angles in a triangle add up to 180. Then 55 plus 90 plus what gives me 180? Well, if I subtract these two from 180, I get 35. So y is 35. And then x is equal to 35. Because these two are angles in the same segment. Because angles in the same segment are equal. So that's the answer. The answer is 35, but guys, make sure you give the reasons. Okay, 35 degrees. Okay, question 15. Using algebra, prove that given any three consecutive whole numbers, the sum of the square of the smallest number and the square of the largest number is always 2 more than the square than twice the square of the middle number. Okay, that's interesting. So we're going to we need to use a general number. What letter do we usually use? Well, n. So let n be a whole number. But I'm going to let n plus 1, and n plus 2 be 3 consecutive whole numbers. So obviously n is just any number, and then it's the next number would be n plus 1, because we just add 1, and the next one would be n plus 2. Okay, fine. So it says the sum of the square of the smallest number. So the smallest number and the square of the largest number. So we're going to get n squared and n plus 2 squared. So n squared is obviously n squared, but let's do n plus 2 squared. N plus 2 squared is equal to n squared plus, guys, this is, just be careful, it's n plus 2 times n plus 2. So it's n times n squared, plus 2n, this times this, plus 2 times n, which is plus 2n again, and then plus 4, 2 times 2. And this is equal to n squared plus 4n plus 4. Okay, now that is the biggest number squared. The sum, let's just write it clearly, sum of the square of smallest and biggest will be n squared plus this, because the smallest one is n, so we're doing n squared, which is this, and 2 plus n squared, which is this. So this becomes n squared plus 4n plus 4. And this is equal to, just add the 2n squareds, and we get 2n squared plus 4n plus 4. Okay, he's saying that this is always 2 more than twice the square of the middle number. Right, let's get the middle number squared. The middle number squared is equal to n plus 1 squared. And this is equal to n squared plus n, which is plus 2n plus 1. Again, guys, you just do that separately if you're not sure. This times this, this times this, this times this, and this times this, and you get that. Okay, so that's n plus 1 squared. And we are going to get twice this, because he says twice the square of the middle number. So 2n plus 1 squared is equal to 2 times this. 2 times this. Now to multiply this by 2, you have to multiply all of the terms. So 2n squared plus 4n plus 2. Now you can see that this and this are similar, but this is 2 more than this. So this 2n, I'm just going to draw a line here. We just finally have to show, therefore 2n squared plus 4n equals, or no guys, sorry, let's do, I'm going to add 2 to this. Therefore 2 times n plus 1 squared plus 2 is equal to this 2n squared plus 4n plus 2, this plus another 2, which is then 2n squared plus 4n plus 4, and this equals this. Therefore equal. I don't want to write the whole thing out again, but that's definitely full marks. So this, the square of the smallest number plus the square of the biggest number, is equal to 2 more than 2 times the square of the middle number. Okay, so it's obviously not complicatedly worded, or it's just a complicated question, but that's it. Okay, question 16. An arithmetic series has first term 1, common difference 4, find the sum of all the series from the 41st term to the 100th term. Okay, so there's a kind of trick to do this, guys. We can do the first, let's just look at the terms. So we've our first term, second term, third term, fourth term. The first term is 1. So this is n, this is u of n. Okay, now let's make a table. The first term is 1. The second term is plus 4, so it's 5. The third term is 9. The fourth term is 13. I like to write out the series, guys, to get my head around what's actually happening, at least a few terms. Okay, and then we're going to go dot, dot, dot. We're going to skip a few. And we're going to go to, we'll skip a few here. We're going to go to the 41st term. Well, actually, before I go to the 41st term, let's do the 39th, 40, 41, 42. Sorry, guys, that's a bit squashed. 40, 40, 41, 42. Then dot, 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 up to 100 here. Okay, now I don't know what these terms are, and I'm not too bothered at the moment. But what I'm trying to get, the point I'm trying to make is the terms that I want are going to be these terms. The sum of the 41st to the 100th term. Which means what I don't want, and this is important, what I don't want, and I'll do this in pink, are these ones. So essentially I want, because guys, it's difficult to get the sum from the 41st to the 100th term. What I can do is I can get the sum of the first 100 terms and subtract the sum of the first 40 terms. That's a way to do it. Or I could just get the 41st term and add up the 41st term, the 42nd term, and then get the 100th term and add that up. But I think I'm going to go, I'll get the sum of the first 100 terms and I'll subtract the sum of the first 40 terms. Okay, so S of 100 is equal to n over 2. So let's write the formula here, guys. This formula is in the formula sheet, FYI, but it's Sn equals n over 2, 2a plus m minus 1d. That's in the formula sheet. So S100 is 100 over 2 times 2 times 1, because the first term is 1, plus 100 minus 1, 100 minus 1 times d, which is 4. That I can just put straight into the calculator. So that is 100 over 2, which is 50. Okay, let's just do 100 over 2. 100 over 2 times 2 times 1 is 2 plus 99 times 4. I've skipped a few steps, guys, but there we go. It's 19,900. 19,900. The sum of the first 40 terms is similarly 40 over 2. 2 times 1, because the first term is still 1, plus 40 minus 1 times 4 times d. And this is equal to, similar thing, 40 over 2 is 20. 20 times 2 plus 39 times 4. So again, guys, I've skipped a few things in my calculator, but make sure you understand what I did. All right, so the sum of the first 40 terms is 3,160. 3,160. Now this is key. The sum from 41 to 100 is the same as the sum to 100, which is everything, minus the pink ones, and this is the pink ones. So sum of 100 minus sum of 40 is equal to 1,900 minus 3160, and this is 19900 minus 3160, 16740. This is 16740. Okay, that's the answer. Now guys, you could have done an alternative method is find the 41st term, then find the 100th term, and then just apply the rule. But it's a little bit more complicated in my opinion, although you should get the same answer. Okay, question 17. Venn diagram. We have A, B, C, fine. These represent the numbers of elements. So guys, I always find this confusing. Be very, very careful. This means there's 6 elements here. There are 3 elements there, etc. So the number of elements in A union B. So that's A union B is going to be this, 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 and this. It's in anything in A or B or both. I don't care about C. So 2 is in B, so it counts. 3 is in A and B, it counts. 6 is in A, it counts. 8 is in B, it counts. They all count. So the answer is this plus this plus this plus this. Now it's not 4. These are not elements. These are the number of elements. So just be careful. So I add them. 9, 17, 19. So this is 19. Okay. Let's actually delete the pink just so in case we need it for the next question. Okay. A intersection C. The number of elements in A intersection C. Okay, there is no intersection because there's no numbers. These don't meet. There's no numbers in A and C, so this is just 0. Okay, the number of elements in B and not C. So this means in B and not in C. Who is in B and not in C? Well, he's in B and not in C. He's in B and not in C. So it's these two, which gives me 11. 8 plus 3 is 11. And finally, how many are not in A, union not in B, union not in C? Okay. Not in A, right? This, guys, is a bit tricky. So it's, let me write it again. It's the number of elements that are not in A, union not in B, union not in C. Now, because it's union, I'm going to write them all down. So who is not in A? He is not in A, he is not in A, he is not in A, and he is not in A. They're not in A. So they're all included. Okay, union not in B. So I'm going to write down everyone who's not in B. He's not in B. He's not in B and him, but I've already counted them. And then not in C. Well, there's only one guy left, and he's not in C, so I'm going to include him. So this is actually kind of a trick question. It's everything, all of the numbers. So we have 9, 13, 21, 23, 28. So the answer is 28. Okay, that's question 17. 18. Okay, 3 solids A, B, and C are similar such that, okay, this is question 18, guys. It's hard, obviously. It's the surface area of A to B is this, and the volume of B to C is this. Work out the ratio of the height, right? So they're combining 3 different shapes and 3 different, 2 different scale factors. So let's do it like this, guys. I'm going to say, let's do A, so A to B. Now, if you've seen me do these similar shape questions before, guys, I always do scale factor, area factor, and volume factor. Which one do they give us? So whichever one they give us, we can work out the other 2. So from A to B, they're giving us the area factor. It's 4 to 9. Now you could leave it as a ratio, or you could just put it as 9/4. Ratio and fractions, guys, is basically the same thing. But that means the area of B is 9/4 times bigger than the area of A. Okay, once I have the area factor, I can get the scale factor by getting the square root of this. The square root of this, use your calculator if you need to, guys, but it's 3/2 because it's √9/√4. And then I can get the volume factor. I don't think I need it, but let's just do it anyway. 3/2 cubed is this cubed, 27, over 2 cubed, 8. Again, use your calculator if you need to. Okay, that's A to B. Then he gives us B to C. B to C. B to C, same thing. I'm going to write scale factor, area factor, and volume factor. But for this, he gives us the volume factor. And it's 343 over 125. Again, if you want to stay in ratios, that's not a problem. Okay, that means to get from volume factor to scale factor, I always go back to scale factor, I get the cubed root of this. The cubed root of this, guys, is 7 over 5. Again, use your calculator. And guys, I actually have used my calculator. It's 7 over 5. Which means the area factor, square this, is 49 over 25. Okay, now the question says work out the ratio of the height of A to the height of C. Give your answer, give your ratio in its simplest form. Okay, so from A, I'm going to go A to C. Now, because he's talking about height, we only care about scale factor, because height is, well, it's just the height. It's not the area and it's not the volume. So I'm just looking at the scale factor. Now, to get from, and this is why I bring it back to fractions, guys, to get from A, the height of A to the height of B, we multiply by 3 over 2. So from A to B, we multiply. Let's just do this up here at the side. We're going to multiply. To get from A to B, we're going to multiply by 3 over 2. And then, we're at B. This is the height of B. To get from B to C, we multiply by 7 over 5. So to get from A to C, I have to multiply by 3 over 2 and then multiply by 7 over 5. And this gives me 21 over 10. So the scale factor from A to C is 21 over 10. Okay, and that means the ratio is 10 to 21. Just make sure you put it in the right order. 10, or A is obviously the smaller one, so we do 10 to 21. That's height of A to the height of C. Okay, that is question 18. Question 19. Given this, find the value of M. Okay, so guys, this is, don't let the M freak you out thinking, or make you think this question is like impossible. He's basically saying simplify this, or write it as x to the power of something. And once you do that, you'll get M. So let's just focus on this thing here. So the root 1 over x. So okay, we have 1 over x. Let me write this whole thing out. It's 1 over x to the power of 4. Sorry, it's the cube root of 1 of x to the power of 4. Now I have a thing, guys, called, my students will be familiar with this, called flower power. Flower power is where underneath the fraction, so if we have 4 over 3, underneath the fraction is, I don't have a brown, okay, the root, this is the root underneath the ground, if you like, and above the ground is the power, hence flower power. So the 4 is the power, the 3 is the root, root power, flower power. So 3 is underneath, 4 is on the top. So I'm going to change this. Instead of root, I'm going to put 1 over x to the power of 3, sorry, I did it the wrong way, 4 over 3. Because 3 is the root and 4 is the power, hence the overall power is 4 over 3. Okay, and then finally, and I know this is tricky, guys, finally, I need to change 1 over x into x to the power of something. Well, 1 over x, the reciprocal is x to the power of minus 1. You need to know that. X to the power of minus 1 is 1 over x. So now I have x to the power of minus 1 to the power of 4 over 3. And this is now our third law of indices, where I just multiply the powers. So this becomes x to the power of minus 4 over 3. And just be very careful, guys, this is only 1 mark, incredibly. Why are they being so mean with 1 mark? Okay, that means m is minus 4 over 3. Okay, fine. Next, or part B. Express this in this form. Okay, so guys, again, if you've seen my previous solutions, you'll see the way I do this is I go to the equation, go to polynomial, go to degree 2, and I write in here 3, 12, this is from the question, and 19. And I get an x1 and an x2 that I don't care about, and I get the minimum is at minus 2, 7. So I'm just going to write here min at minus 2, 7. Now if the min is at minus 2, 7, this thing can be written as 3x squared plus 12x plus 19. Can be written as, the a is always 3. It's always this, not always 3, sorry, it's always this, whatever is in front of the x squared. So that's 3. It is then x minus this. Now it's x minus this, but this is minus 2, so it's x plus 2, minus 2, or x plus 2 squared, and then the next bit is just plus 7. And that's it. That's by far the easiest way to do it, guys. Okay, that's question 19. Question 20. The curve with equation. This has one turning point. The coordinate is this. Write down the coordinates. The coordinates of the turning point on the curve with equation this. Right, this is an example. I'm always telling my class guys that these last questions, yes, a lot of them are hard, but there are some, like this one, that's easy. All you have to do is go up 5. The transformation is we're adding 5 up, which means we're going to add 5 to the y coordinate. So it becomes the x coordinate stays the same, and we do minus 4 plus 5, which is 1. Okay, this one, okay, not as easy. This is a horizontal stretch. So it's a horizontal stretch, scale factor 1 over 3. So we're going to multiply, that's right, multiply x coordinate, because we are horizontally stretching it because it's inside the bracket, multiply x coordinate by, didn't need to put that in a bracket, guys, multiply x coordinate by 1 over 3, because you always do 1 over whatever is there. So I'm going to multiply this by 1 over 3, which is negative 2, and the y coordinate stays the same. Okay, the graph of y equals g of x is shown on the grid. Sketch the graph of y equals 2 g of x for minus 1 to 7. Okay, be very careful, guys. This is super important. Don't go past minus 1 or past 7. Okay, so essentially, because it's just 2g of x, we're going to multiply. I'll write it here. Multiply, because the 2 is outside the brackets. We're going to multiply the y coordinates. Coordinates by 2. So go to 1. We'll start here. The y coordinate is 3. Multiply by 2 goes to 6. This y coordinate is 2. Multiply by 2 is 4. This y coordinate is 1 multiplied by 2 is 2. Y coordinate is 0 multiplied by 2 is 0, so the x coordinates stay the same. This is -1 times 2 is -2. 0 stays the same, and then you start to see the pattern. This times 2, 2 times 2 is 4, and just be careful, guys, we're doing only to 7. I guess we can't go past 7 anyway because it goes off the grid, but it's 3 times 2 is 6. Join the dots, and we get a very nice, well, not that nice. Okay, that's a bit better. And that's it. Okay, I would argue, guys, we can all do that question. Oh well, hang on, we're not finished. The graph of y equals h of x intersects the x-axis at 2 points, this and this. The graph of y equals h of x plus a passes through the points with coordinates 2, 0, where a is a constant. Find the value of a. Okay, fine, this is hard. So what's happening, guys, what's happening is, this is, okay, there's some graph, and it, what I'm going to do, guys, is I'm actually just going to draw some random graph here. Now it really doesn't matter what my graph looks like, but it's going to go through, it has to go through -1, -1, 0, and 6. 2, 3, 4, 5, 6. Okay, that's -1, and that's 6. So let's say the graph, for argument's sake, looks like this. Okay, doesn't matter, but it goes through these 2 points. Now this question is about transformations. So the graph of y equals h of x plus a. So we're going to move the x plus a, means we're going to move it left or right. We're going to move it left or right by a. So we're either going to move it right a or left a. Now watch this. I'm going to draw another one of these. Now obviously, guys, you don't have to do this, but I'm just showing you what's happening. So this graph, let me just change the color to pink. Okay, so we're going to move this graph, and we're going to move it such that it lands on the point 2, 0, because he says, let me just underline this, he says the new graph lands or passes through the point 2, 0. So this is 2, 0, and 2, 0, let's just say, is here. This is 2, 0. Well, let's just put 2. Okay, so my question is, if we're here, how can I get the x coordinate to now be on 2? By moving it left or right. Well, look, you can see I'm going to move it right. Now it is on it is on 2. It crosses the x-axis at 2. Now, how much right did I move it? Well, I've moved it from -1 to 2, so I've moved it right 3. Right 3. Therefore, a is equal to -3, because we always do h of x minus 3 will h of x minus 3 moves it right 3. Similarly, because he wants two coordinates, I could move it left to there. Now, at this point, if I move it left this much, it also crosses at 2. How much have I moved it left? Well, I've moved it from 6 to 2. So I moved it left sorry, 4. From 6 to 2, I've moved it 4 to the left. If I've moved it 4 to the left, therefore a is going to be plus 4, because if I do x plus 4, h of x plus 4, that moves it left 4. Okay, so that's fair enough, guys. That's a difficult question. But the answers are minus 3, that's the one that moves it right 3, or 4, That's the one that moves it left 4. Okay. Next question. Question 21. Histogram, guys, I should probably check how. Okay, it's only 3 marks. It's not too long. Histogram gives you information about the weights of all the watermelons in a field. There are 16 watermelons with a weight of between 8 and 8.5. Okay, guys, I'm very used to seeing this type of question. So this here, remember, and I often write at the top, area equals frequency. So that's like the main thing, the main point you need to know. The area equals frequency. Let's just write it, leave it here. So, and the left, the frequency density axis is not the frequency. And when I say frequency, I mean how many watermelons. Okay, so it says there's 16 watermelons between 8 and 8.5. That's in here. There's 16 there, which means the area of this is 16. Okay, now if I do, guys, that's actually hard to see. That's 16. Okay, now how do I get the area? Well, it's base times height. So the base is 0.5. So 0.5 times the height, let's call it h, is equal to 16. Therefore, the height has to be 16 divided by 0.5, which is 32. That means this value here is 32. If I go across, this is 32. Okay, now if this is 32, that helps me because now I can say this is 10, this is 20, this is 30, and this is 32. And these boxes are actually just going up in ones, so that makes my life much easier. Okay, work out the total number of watermelons in the field. So all I need to do now, guys, is get the total area. So it's just base times height, base times height, base times height, base times height. This guy is 1 times 15, which is 15. This guy is going to be 1 times 23. This guy is 1 times 30, which is 30. And this guy is 1.5 times 12. 1.5 times 12 is 18. Now, fair enough, guys, you probably do want to write down that working somewhere. Just write it down below here. 1 times 15 equals 15. This one we know, it's 0.5 times 32. This one, 1 times 23 equals 23. 1 times 30 equals 30. And 1.5 times 12 equals 18. So the total equals, we just add these up. This is 38, 68. Oh, hang on, I forgot the 16. So, well, I'll add the 16 after. So it's 15 plus 23 plus 30 plus 18 plus 16, 38, 68, 78, 86, 96, 102. So when I add all these up, I get 102, and that's right. So there's a total of 102 watermelons. Okay, question 22. The diagram shows a triangle ABC. We have CX and Y given to, well, whatever they're given to us is calculate an upper bound for the value of B. Okay, B needs to be big. Okay, so in order for this side to be big, if you just look at it kind of intuitively, we want this angle here, this angle to be big. Because the bigger this angle is, the bigger this line will be, because it's opposite this. So just imagine Look, just imagine I make this angle bigger, well then I make the line, this line, bigger. Like so. Okay, so I want this to be big. Now this angle, let's call it theta. To make theta big, I need to make x and y small. So I'm going to make x and y small, and I'm going to find theta first. So to make y small, I always draw out these lines, guys. I'm going to make y, x, y, and I also have c, remember? So let's put another one in for c. So this is x, y, c. Okay. X is 80 to the nearest whole number, so the next whole number up is 81, and the next whole number down is 79. Y is also to the nearest whole number. It is 75. The next whole number up is 76, and down is 74. And then C is 11.5, nearest decimal place, so the next decimal place up is 11.6, and the next down is 11.4. Okay, we want the lower bounds for x and y. We're going to make them small. So x, we're going to put the lower bound is here. This is halfway between these two, so it's 79.5. And this guy's lower bound halfway between these two, 74.5. Okay, therefore theta, and guys, I'm just going to write up here so we can all see it. Theta is 180, because it's a triangle, minus 79.5 minus y, which is 74.5. So if I subtract those two, I'll get theta, the theta that I want at least. So it is 180 minus 79.5 minus 74.5, which is 26. Okay, so the theta that I'm going to use is 26. Now, how do I find b? Well, it's not a right angle triangle, so it's either going to be cosine rule or sine rule. For the cosine rule, I need the two other sides and the angle between them. I don't have this side, so it's going to have to be the sine rule. So I'm going to start with what I want. I want b, so I'm going to do b over sine. And guys, actually, I'll start up here again, so I have space. You obviously write down here. So it's b over sine theta is equal to b over sine theta, this over sine of this, is equal to c over sine y. Now, b is equal to, therefore, c sine theta over sine y. Now, we've already said we're using the lower bound of x and y. Well, y. I know theta I'm just going to be using as 26. The c, though, do I want that to be big or small? Well, because it's in the numerator and I want b to be big, I want c to be big as well. So c is actually going to be the upper bound. This is 11.55, halfway between these two. Add them and divide by 2. So I'm going to be using this this c. Therefore, the upper bound for b is c, which is 11.5, times sine 26 over sine y, which is 74.5. These guys, these questions are hard. The ones that mix the sine rule with the upper and lower bound stuff, but this is how you do it. Okay, so it is 11.5 times sine 26 over sine 74.5, and we get 5.231. 5.231. Actually, guys, sorry, I've just made a mistake. It's 11.55. That's an error here, guys. 11.55 times this. So let me go back to that, and I put 11.55, and I get 5.25428. 5.25428. Three significant figures, so it's 5.25. Okay, that's question 22. There's just two questions left, guys. Question 23. Two particles P and Q move along a straight line. The displacement is this. This is the displacement of P from O. Okay, fine. This is the displacement of Q from O. Find the range of eyes of T for which both particles are moving in the same direction along the straight line. Okay, guys, this, I will warn you, is going to be really difficult. So it's moving along the straight line. So it's either going forwards, or both of them are either going forwards or backwards. Let's say forwards means the velocity v is positive. Here v is negative. So to determine which direction they're going, it's all about velocity. So we need to get the velocity. If you recall, guys, this is a kinematics question. Velocity, we differentiate the displacement. So I need to differentiate this and this. So let's do them both. S is t cubed minus 4t squared plus 5t. And x is t squared minus 4t plus 4. Okay, this guy's derivative, ds dt, that's the derivative. This is equal to 3t squared, multiply by 3, subtract 1 from the power, multiply by 2, subtract 1 from the power, and this just becomes 5. Differentiate this, dx dt, it's still going to be velocity, dx dt, 2 times t minus 4. So that's this guy's velocity, that's this guy's velocity. Okay, so guys, I often say everyone can pick up some marks. Now this is, like, obviously it's a really hard question. It's 6 marks, but everyone can at least differentiate these two things. Okay, now this is the hard bit. When we've differentiated, we need to find when is this velocity positive and when is it negative. So let's start with the easier one. This one is easier because it is a straight line. So when is his velocity positive? Well, his velocity is 2t minus 4. So his velocity is positive when this is greater than 0. When this is greater than 0, we have 2t. Let's write here positive. Positive. When 2t so it's positive when 2t minus 4 is bigger than 0. 2t is bigger than 4. 2t is bigger than 4, and t is bigger than 2. So his velocity is positive when t is bigger than 2. It's negative when t is, well, let's write it here, negative when t is less than 2. Simple as that. And when t equals 2, it's actually stationary, because that's right at the moment where he turns around. So he's going, this guy, Q, is going forwards, and then after 2 seconds, he goes backwards. Okay, this guy, what's he doing? Well, This is the harder one because we need to do where is, and again I'll do positive, so it's positive, positive, this is positive when, sorry guys I have to do that, it's positive when 3t squared minus 8t plus 5 is greater than 0. Now I can solve this with my calculator. 3t squared, so I'll go to menu, inequalities, degree 2, bigger than 0, so that's the first one. I put 3, negative 8, and 5 in here, and I get an answer. X is less than 1, and x is bigger than 5 over 3. So x, and I'm going to leave a bit of space here, I'll show you why in a second. X is less than 1, and x is bigger than 5 over 3. X is bigger, sorry, it's t though, t. So t is less than 1, and t is greater than, is that what he said? T is greater than 5 over 3. Okay. Now the reason I've left a bit of space, guys, is we need to factorize this, which is a bit annoying. Now the factors are, if we go backwards from this, it's t minus 1, because you subtract the 1, and here we times by 3 and minus 5, giving me 3t minus 5. So you do want to put in those two factors just to show the working. Okay, so now this guy's positive when t is less than 0, and when t is greater than, sorry, less than 1, and when t is greater than 5 over 3. That means t is negative, this is negative, the other way. So I don't have to do it all again, but if it's positive when it's less than 1, it's then it is then negative when it's greater than 1, when t is greater than 1, but less than 5 over 3. Because when t is greater than 5 over 3, that means it's positive. Okay, now all we need to do is decide which t's, are they both going positive or are they both going negative? Okay, so the first thing to note is this guy is only positive when t is greater than 2. So I'm just going to focus on these two. Therefore, both positive, I'll stick with my green, both positive when this guy's only positive when t is bigger than 2. And this guy's positive when t is less than 1. I don't even care about that because I can almost ignore this because t has to be bigger than 1 anyway. It says it here, look, t is bigger than 1. So I don't even have to worry about that one. This is only positive when t is bigger than 2. And this is positive when t is bigger than 5 over 3. Now 5 over 3 is, as a decimal, well, it's 1.66 recurring, or 1.6 recurring. This is obviously less than 2, so they're both positive when t is bigger than 2. And they're both negative when, well, this guy is only negative when t is less than 2, so I'll say both negative. He is only negative when t is less than 2, and he's negative when t is less than 5 over 3. So both of them are negative when t is less than, again, this is less than 2, so both negative when t is less than 5 over 3, because then it's this guy's less than 5 over 3 and this guy's less than 2. They both it both has to be satisfied, and t obviously has to be greater than 1. Now I could put in t is greater than 1, but it says find the range of values of t where t is greater than 1. So I don't even need to put in t is greater than 1 here. So that's the answer. Guys, fair enough. That's actually really confusing because it combines calculus with kinematics with quadratic inequalities, which by themselves are like one of the hardest topics. So look, if you can't do that, don't freak out, unless you want to get a 9, in which case you do need to do that. You need to know how to do every question. Okay, final question, guys. A vectors question. No doubt this is going to be horrible too, but here we go. Question 24. OXYZ is a trapezium. We've OX is A, XY is B, and OZ is 3B. Let's put these in first, guys. I have OX is A, and M is the midpoint, so this is actually just a half A, and this is a half A. And OZ is B, and XY is B, and OZ is 3B. And these are parallel, guys, these two, because it's a trapezium. Okay, he then says, given that ON to OY, so this thing here, the ratio is lambda to 1. Use a vector method to find lambda. Okay, so I think I said in the last video, guys, these are hard. These are really difficult questions, but I at least am starting to, because I've done quite a few of them now, I'm starting to see a pattern. They're all quite similar. Not easy, still not easy, but at least similar. What I need to do is find a way to get from O to N, in this case, in two different ways. The first way I'm going to go is just straight across. I'm going to go across this way. Now he has said that ON is a fraction of this full length OY. This is OY, and ON is a fraction of that, and the fraction of it that it is lambda, because it's lambda to 1. Lambda to one of these. So this isn't, the vector isn't lambda, but the fraction of the full line is lambda. So I'm just going to put lambda in there so we know what the fraction is. The other way we're going to go is this way, up and down. Now you essentially have two ways. You could go this way or you could go this way. Both pretty similar in terms of ease, guys, but this way maybe slightly easier. Okay, now what fraction though is mn of this full line? Well, we don't know, so we're going to make up, they've given us lambda. Let's use the other Greek letter that we use very often, mu. So this is mu times the full thing. So that is what fraction of the full line is this mn here. Okay, now let's go from O to N in our two different ways. Let's start with this orange way. So the first way, let's just call it the first way to get from O to N, ON, is equal to lambda times OY. It's lambda times OY. It's just this fraction of the full thing. Now we have OY, guys, because OY is just A plus B, because it's OX plus XY. It's just A plus B. To get from here to here, I can go up A across B. So this is A plus B, and multiplying that out equals lambda A plus lambda B. Okay, the second way, this pink way, is I'm going to go up. So this is ON. I'm going to go from O to M, so O to M, and then plus some fraction mu of the full thing mz. So it's plus mu times mz. Okay, now I know OM, guys. It's right here. It's a half A plus mu times, I don't know mz, but I can find it. I'll do it up here, guys, just so I can keep space here. You obviously do it down there. Mz is equal to, To get from m to z, I'm going to go I'm going to go minus a half a. So minus a half a plus 3b, plus 3b, because I'm going down this way and along this way. So that's mz. So this is mu times minus a half a plus 3b. Okay, let me just get a bit of space. Okay, I'm then going to multiply this out. This is a half a minus a half mu a minus a half mu a and plus 3b mu, or 3 mu b. Okay, now I have on this way and I have on that way. What I can do is I can equate things. So I'm going to equate the a's. Here my a is lambda. Here my a is a half minus a half mu. It's basically the coefficients of a. This must equal this. And then I have, let me choose a different color. I have my b's. This is b, lambda b, and this is b, 3 mu. So I essentially have two simultaneous equations and I can just solve them. The first one is lambda equals a half a minus a half mu. Sorry, not a half a, what am I doing? It's a half minus a half mu. It's just the coefficients of a. And the second equation is lambda, the gray ones, lambda equals 3 mu. So just to be clear, guys, this is the gray one and this is the green one. Okay, now if lambda is 3 mu, I can just, I'm trying to find lambda, guys, so I can just sub in instead of mu. Okay, let's do it this way. I'm going to multiply everything by okay, well, firstly, guys, you can use your calculator using simultaneous equations. The way I'm going to do it here may be slightly tricky, but I'm going to sub this 3 mu into here instead of lambda. So instead of lambda, I have 3 mu equals a half minus a half mu. Then I'm going to multiply everything by 2. So I'm just going to move down here, guys. Because I'm trying to solve this equation, I'm going to multiply both sides by 2 to get rid of the halves. So this times 2 is 6 mu. This times 2 is 1. And this times 2 is minus mu. So mu, or 7 mu, I'm going to add mu to this side. 7 mu equals 1. Mu equals 1 over 7. And when I have mu, I can easily find lambda, because lambda is 3 mu, which is 3 times 1 over 7. Lambda equals 3/7, and that is correct. Okay, as I've said, guys, at the start, that's obviously a very difficult question. That's the paper finished. Let me know what you think in terms of difficulty. I think probably about average. Okay, that's it, guys. I'll see you in the next video.